I have a list of problems. I have a list of about 12 problems out here. Let us solve about out of 12. Let's solve about 5 out there. I'm going to put up all these 12 problems on the course material part of it. Let me consider this second problem. You are considering two independent projects having different requirements. Project A is required 12% return compared to project B's required rate of return is 13.5%. Project A costs 75,000 and has cash flows is given from 1 to 3. Project B costs 70,000 and has cash flows. Based on the project NPV, which one should you choose out there? Let's take up this problem as we discussed. Now let's go to the Excel sheet. I basically got these numbers typed in on the Excel sheet out there, as you can see. That is project A. If I look at required rate of return is 12%. Both the required rate of return for both the projects are different. Sir, how do we do it? You can of course do it by calculating what is the present value of each, that is present value of A, present value of B. I can certainly do it that way. That is, what do I do? Present value of A, the year of investment is exactly the same. Sorry. Present value of B, okay, this 21,000 I discount it for 1 year. I discount it for 1 year, 1 plus this 10% out there, 12% to the power of 1 out here, of course to the power of 1, because I am going to discount it only for 1 year. And then I have what is called as the present value. I can use this cash flow out there. I can discount it for basically 2 years out there, 1 plus this 12% out here, and then I take to the power of 2, and then I can discount it out here, and then I can go on discounting the third year cash flow, and then I can say what is the final NPV or whatever it is. But now that we are using Excel, let me try use the Excel function out there. I will try and use the Excel function. I will just say NPV tab. It gives me, as you can see, rate, value 1 and value 2 and so on and so forth. Or else I can just go here to auto sum. I can say more functions. I can click on what is called as NPV out here, and I have my NPV in this particular case. What is the rate? Rate is 12%. What is the value in this particular case? The stream of cash flows. I completely highlight it out here, and then I will say I am just going to click it, and the NPV of this project is negative 7,719. So I will reject this project. I will go to project B. In this particular case, I will do the same NPV. Of course, you can do that and calculate it. I am not denying that. There will be slight variation in your number calculations out there. Numbers out there. So let us sort of do that NPV out here. Rate 13.5. Cash flows out here. Yes. This is my NPV, and unfortunately, like exactly the same example I took, both these give negative NPV. So reject both, as both give negative NPV. That's all. We will take up the next numerical out here. I will skip third, fourth out there. Payback period, which you can do it. I talk to you very easily out here. Let us look at the fifth problem. Let us say discounted payback period. I think discounted payback period. I think, yeah. Let's see. Jack is considering adding toys to his general store. He estimates the cost of the toy inventory will be 4,200. The remodeling and shelving cost will be 1,500. Toy sales are expected to produce an annual cash inflows of 1,200, 1,500, 1,600, 1,750 over next 4 years respectively. Should Jack add toys to his merchandise if he requires a 3-year payback period? Why and why not? Very simple question. Let's go to the Excel sheet. So in the Excel sheet, I've got the years of cash flows and the cash flows out here. Let me first calculate the cumulative cash flow. Well, I need to have the cumulative cash flow out here. So what happens? My cumulative cash flows out here in this particular case, first year is 1200, yes. Second year is 1500 plus this out here 2700. Third year is this plus this out here 4300. Fourth year I have this plus this, great, 6050. But what is the question? The question says, will he complete it in 3 years? That is, if he requires payback period is 3 years. In this particular case, you see, cumulative cash flows I calculate. He has got, in the third year, he's got only 4,300, whereas your cash outflow is 5,700 out there. That is, in this particular case, 5,700. Why 5,700? He has got 4,200 as inventory and another shelving cost of 1,500. So 5,700 is the total basic cost out there. So payback, what is this payback period? Payback period is, for example, in this particular case, it's going to be the third year plus this is going to be the cash outflow minus this is what he has so far got. That means what is the remaining what he has to get. Let us divide that by what do we call it as the money that what he is getting in the fourth year out there. That will give me 3.8 years it takes for him basically to get the return. So what happens? It does not, the cash flow, the project does not meet his requirement of payback in 3 years, as the project takes 3.8 years to pay back. I'm just going to wrap this text and then let us see this. Right. Now let's try and see if we can do 3 more problems out there. Let's go to problem number 9 out straight away. 9 we are not doing, profitable index we are not done. No, 9 IRR. Yeah, let's go to problem number 9. Very simple. A financing project has an initial cash flow of 42,000 and cash flows of 15,600, 22,200 and 18,000 in years 1, 2, 3 respectively. The required rate of return is 13%. What should be the IRR should the project be accepted? Let us go back to the Excel sheet. Look at this. I have year 1, 2, 3. Cash flows are given as it is from the problem. 15,600, 22,000, 18,000. Yes, we have got that everything out here. Required rate of return is 1,300. Required rate of return is 13%. Now I'll say IRR. All that I have to do is I will just go to more functions. There are some out here. More functions. I will just type IRR in this particular case. It gives me what is the IRR. What are the values out here? These are the values out there, and then I will just say click. So what happens? IRR is 15.26% out there is the IRR for this project. IRR 15.26. But please note, in this particular case, all this is basically what you call it. This is what we call it as a financing project out there. You have borrowed 42,000. That is where there is no negative 42,000. You have borrowed 42,000 and you are paying off. What is this? So what happens in such cases? Since it's a financing project, a IRR which is higher than the required rate of return will be rejected because it is not viable. The project, your required rate of return should be higher than 15.26. Only then the project is viable for you because you can borrow and sustain there. Let's move to the next problem out there. There's one more concept that we call about as profitability index. I did not cover it in the slide out there. Let me go back to the profitability index part of it out here. What is profitability index? It is nothing but the total present value of all the cash flows divided by the initial investment. That gives you a percentage out there. Total present value of all the cash flows. I will calculate the present value of all the cash flows divided by my initial investment. That is all what we call about profitable index. Acceptance criteria, profitable index should be greater than 1. If it is greater than 1, then it is viable project, accept it. That's all. That is all what we talk about in profitability index out there. Of course, it has same problems of mutually exclusive projects and so on and so forth. So, in that context, let us take problem number 10. Johan is considering two independent projects. A, 44,000 as a projected cash flows are so and so. Years 1 to 3 respectively. B, whatever it is, 70,000 and then cash flows are so on and so on. Johan assigns a discount rate of 10% for project A, 12% for project B. Which project, if either, should be accepted based on the profitability index rule? That's all what we call it. Let's go to the Excel sheet. So look at the Excel sheet out here. I have years 0 to 3, project cash flows, and etc. What am I going to do? I'm just going to calculate the present values of the cash flows out there. I'm just going to calculate the present values. You can have a present value figure put out there. That is, what is it? 1 by 1 plus, what do you call it as 10%? 1 by 1 plus 10% out there. I can just do it. 1 plus, and then out here in this particular case, I can use this. And then give that figure out there, 0.99, that is what is the multiple. So I will say the present value is of this is this multiplied by, what do you call it as the 8,700, I've got it out here. Or I can just straight away calculate what is the present value. I will just divide this by 1 plus 10% to the power of 2 out there. I'm just done. And I'm just going to use the same thing out here. Divide this by 1 plus 10% is the project cash flows to the power of 3 out there, and that's it. Yeah, I'm just going to reduce all the decimals. In this case, I'm just going to reduce the decimals out here. So the present value of this cash flow is basically going to be the same thing out here. It's not going to be very different. This is all the cash flows. So what is the present value of all the cash flows? The present value of all the cash flows, present value of all the cash flows out there, I'm just going to be auto sum. What is this? This is not the one, no?
We only need the present value of cash inflows.
Cash inflows. So I've basically done this. I can do the same thing for this project also. This is this divided by 1 plus whatever is the 12% out there. Yes, I've done this out here, and so on and so forth. In this particular case, this is the one divided by 1 plus 12% to the power of 2 out here. I just have to add one more parenthesis brackets out here. I'm done. And then in this particular case, it's going to be this particular cash flow divided by 1 plus this 12% to the power of 3 out here, and I close the parenthesis. I'm just going to eliminate all the zeros. So what is the present value of all the cash inflows? What I have, the present value of all the cash inflows I have, I'm just calculated this. In this particular case, again, I'm going to eliminate all the zeros. What is my profitability index? My profitability index is nothing but what we call it as we saw in the slide, profitability index, one slide before, present value of future cash flows. Future cash flows, that is why I have not taken the negative, the investment I have not considered. Future cash flows divide by the initial investment out there. That is the present value of all these cash flows divide by the initial investment. In this particular case is 74,600, and that is it, it's 0.86. Whereas in this particular case, this is what is the present value of all the future cash flows divided by 70,000 out there, it's 1.01. So I accept project B, accept project B. That's all. Let us take up what is called as one more last problem out there. I think which is comprehensive, which covers everything. IRR, NPV, profitability index, everything. Let's take the 12th problem. A proposed new venture will cost 1,75,000 to produce annual cash flow of this from year 1 to 4. The required payback period is 3 years, discounted payback period is 3.5 years, the required rate of return is 9% out there, and then which method indicates the project acceptance and which method indicates the project rejections out there. Let us go to this. Now you see the 12th. Let us sort of look at what we call it as, let us calculate each one of it. Let me calculate the NPV, the first one to calculate what is called as the NPV, net present value of the project. Net present value of the project, NPV, it gives me rate 9%, cash flows, this is the cash flows, I'm sorry, I think I made a mistake, NPV, this is the rate 9%, and these are the cash flows I will basically have, and then enter, and then okay, yeah, I will let just two, yeah, and that's it. The NPV of the project is 240.88, positive NPV for this project. Positive NPV for the project. So as per NPV rule, accept the project. Next I will go for something called IRR. What is the IRR for this project? Again IRR. Tab, this is the one, I'm sorry, this is just the cash flows out there, this is the IRR for the project and IRR. IRR is at 9% in this particular case, 9.07% out there. Required rate of return is only 9. So what happens? Higher than the required rate of return. My required rate is 9. The project is giving me 9.07%. So accept the project. Again, I will say accept the project. Am I right? Next, we will do payback period. For calculating the payback period, let me do cumulative cash flows. Cumulative cash flows, let me basically start calculating what we call it as the cumulative cash flows. First year, there is the one, second year, this plus, there is the one, and third year, this plus, there is the one out here, and then fourth year, this plus, there is the one out here. I am just going to eliminate all the decimals out there. So I know that in the fourth year, my project is going to be successful. So what is the method that I am going to use, payback period? So it's basically going to be third year plus what I am going to use out here. This is the cash outflow minus plus this is going to be the extra cash flow, divide by what I'm going to get in the last year. So, what man?
Because the negative, you can just write 1,75,000 instead of.
So, it's going to be, this is the one, plus 1,75,000 minus 1,73,000. So, whatever is the difference, and the fourth year is what I am going to get this. So that is going to be 3.0375 years out there. What is the required payback period? The required payback period is 3 years. So I would say, as per payback period, I reject the project as it exceeds the required 3-year payback. As it exceeds the required 3-year payback, I would basically say that. Now I will say discounted payback period. Let me discount it. Let me say the present value of all these cash flows. That means 48,000 divided by 1 plus this 9% out there. First year, agreed. Second year, 85,000 divided by 1 plus 9% to the power of 2 out there. Yes, third year, 40,000 divided by 1 plus 9% to the power of 3 out here. Fourth year, 40,000 divided by 1 plus 9% to the power of 4 out there. Yes, this is the discounted payback what I basically have. So, cumulative of the PV of cash flows out there, cumulative of the PV of the cash flows out what we are looking at calculating out here. First year is the same, this is the one. Second year, this plus this. Third year is this plus this, and fourth year is this plus this out here. So, what happens in this particular case, if you basically look at out here, it's going to be slightly higher. That is, it's going to take how long it's going to take. The same thing we're going to look at, because your expected is 3 years plus 1,75,000 minus this part of it, divide by what is the amount out here discounted in this particular case. This is the value out here. So, it takes, as per the discounted payback period, again it takes 3.9 years, 3.99 years out there. So, again I would say reject the project out here. I would reject the project out there. The last one I will say profitability index. Profitability index part of it, what we calculated earlier. Profitability index, what did we say? The total present values of the cash flows. What is the total present value of the cash flows? We calculated here anyway. Present value of the cash flows divided by the initial investment, that is 1,75,000. Present value of the cash flow is more than 1. So, accept the project. Accept the project as PI is more than 1 out there. So, there is a comparison. There are all these other problems that are there which you can sort of solve it on your own. So, this completes almost the first part of the finance. Now, we move to the second part of the finance part of it, where we are looking at the best way to source funds out there. What is the cost of capital? What is your capital budgeting decision? What is your CAPM, etc. We will look at that part of it. Thank you.